evening, everyone. Welcome back to the signal and system question discussions from one of the best book of signals that we were discussing. We have discussed some chapters and we continue here today the question series from Oppenheim and Wilsky. The question series from Oppenheim and Wilsky. So very good evening, everyone. Quickly keep on joining and update your friends that the session is now live. Okay. So now we move on towards the next chapter, and that is going to be Laplace transforms. Okay, it's been some gap, it's been some days, we have been discussing it. Okay, so we have discussed, the DTFT, the continuous time Fourier transform, the convolution cases, the continuous time Fourier series cases, the fundamentals of signal and system, all those things we have discussed. And today we move on towards Laplace. Next, we'll move on towards the Z transform. All right, guys, quickly, let's get moving ahead. All right, good evening. Quickly, let students join. Okay, so I'm good, Dreamer, I'm good. So is it so that, chalo, let's get first started and then we'll discuss it up. Just 1 second, I'm waiting. Okay. So Laplace transform for today. Okay. Just wait on for another minute so that we continue. Okay, so let's get started. By the time I'm waiting for something. All right, so there's a regular introduction that you all know. So guys, yes, so now, okay, now Wednesday, that is 8th November. Okay. Just a second. Thank you. Okay, yeah, now let's get moving ahead. Okay, so yeah, Wednesday, that is on your favorite BYJU'S exam prep app, Wednesday, 8th November at 7:30 p.m. All your favorite Joe Shitzer, the Dashing, is going to bring you a free live interactive workshop for all GATE 2025 aspirants. Yes, if you want a roadmap to have, to secure rank under 100 in GATE 2025, what should be your planning from now on? All that things is going to be discussed in this very important workshop. And also, guys, okay, I'm sorry, 11th and 12th of November. 11th and 12th of November. Okay, this time 2 days, Saturday and Sunday. BYJU'S exam prep gives you the chance to appear in the next national scholarship test, and based on the performance on the national scholarship test, you can get as much as up to 90% discount on the GATE preparation programs. Good evening, Bhanu. Very good evening. Okay, so guys, let's get started and then we'll discuss other things. So this is the first question from the Laplace transforms. This is the first question here from the Laplace transform. Determine the Laplace transform and the associated region of convergence and pole zero plot for each of the following functions of time. Okay, now, whatever questions come up, there are few functions which are always important in the Laplace transform discussion. What are that few functions? Let's do a quick review. Okay, the right-sided and the left-sided exponential signal, important results. For e power minus 80 ut, you have the Laplace transform 1 upon s plus a, with the ROC coming out to be sigma greater than minus a. Okay, we'll sketch that also. And for the left-sided signal, e power minus 80 u minus t, if I do, the Laplace transform is minus 1 upon s plus a with sigma less than minus a. The two of the fundamental Laplace transform always to be remembered, and some more I will add on. Okay. Now, as I told you, ROC for e power minus 80 ut. Okay, the ROC is given by sigma greater than minus a, and minus a is the pole location. Let me mark it by the pole as well. Okay, I have just assumed A to be positive, so minus A comes on the negative side, and ROC is to the rights of minus A. The signal is right-sided, e power minus AT ut. Okay, and the ROC is also right-sided. But if the signal is left-sided, what was the ROC? Signal less than minus A. Minus A is again the pole. Okay, because if you look into any of the previous cases, okay, pole, S equal to minus A, the denominator becomes 0, you have the 1 by 0 case, and hence it is the pole. Okay, so here sigma less than minus A. So the ROC is lying towards the left of the pole, that is minus A. This is the pole minus A and ROC is towards the left of this. So signal is what? Left-sided. ROC is also left-sided. Okay, so always remember, let me come to this point, कि whenever the signal is right-sided, okay, it will also be related to causality later on. Okay, the ROC will also be, right-sided. Okay, not right half plane. ROC also will be right-sided. Not necessarily only right half plane. If the signal is left-sided, ROC will also be left-sided in nature. But if a signal is of finite duration, ROC will be entire S-plane. There will be no poles. And if the signal is two-sided, ROC will be a single finite strip. A single finite strip lying between two different poles. Lying between two different poles. Now, whenever the ROC contains okay, whenever the ROC of any Laplace transform contains j omega x's, then the Fourier transform will also exist. Okay, then the Fourier transform will also exist. Okay, you can also say one more relation. See guys, what is Fourier transform? Yeah, relation between Laplace transform. Okay, so you can say that Laplace transform is actually equal to Fourier transform of xt e power minus sigma t. By comparing both the formulas, we know the basic formula of Laplace and Fourier. Okay, so Laplace transform is actually the Fourier transform of xt e power minus sigma t. That way is also you can always remember. And whenever the ROC contains j omega axis, that is the imaginary axis, the Fourier transform of xt will exist. Going forward, before I take up that question, it is also expected that the fundamental Laplace transform pair is always there in your mind. You should never forget it. Okay, even going to the exam hall, gate exam hall, like impulse has the Laplace transform. Well, e power minus at and e power minus at u minus t, both of them I already told you. E power minus a mod t minus 2a upon s square minus a square. ROC minus a less than sigma less than a. Okay, t e power minus at ut derived by the t times property, frequency differentiation property. Laplace transform is 1 upon s plus a whole square. For unit step, you should remember it is 1 upon s, ROC sigma greater than 0. For ramp, 1 upon s square. If it is t power n, okay, if it is t power n, factorial n upon s power n plus 1. Similarly, very important for cos and sin, cos omega t ut s upon s square plus omega square. Sin omega t ut omega upon s square plus omega square. Okay. So now let us come to that first question. So some things to be always in mind before you start solving the question. So let me go to that first one. Okay. So kya hai? First one is we have to write down the Laplace transform and the ROC. Okay, we have to write down both. And first is e power minus 2t ut plus e power minus 3t ut. Whenever two signals are added, remember, okay, Laplace transform will be added and ROC will be such that it contains both. That means ROC you have to take the intersection of R1 and R2. So let us write down first e power minus 2t ut with e power minus 3t ut. Okay. Starting with the first question here. Moving so slowly. Okay, yeah, so what is the A part? You are given the signal xt, which is e raised to the power minus 2t ut plus e raised to the power minus 3t ut, right? What is going to be its Laplace transform? Okay, what is going to be its Laplace transform? Okay, so e power minus 2t ut, dhyan dena, 1 upon s plus 2 simple. E power minus 3t ut, 1 upon s plus 3 simple. But what about ROC? For e power minus 2t ut, ROC sigma greater than minus 2. For e power minus 3t ut, sigma greater than minus 3. And as I'm telling you, whenever you add two signals, you have to consider the intersection of their ROCs. You should consider the information of the ROCs. Okay, so this one is s plus 3 plus s plus 2. That becomes 2s plus 3 plus 2, that is 5 upon s square plus 5s plus 6. Okay, with the final ROC, now you want sigma greater than minus 2 as well as greater than minus 3. So, you want sigma greater than two numbers. So, it should be greater than the greatest number. So, greatest is minus 2. Out of minus 3 and minus 2 is bigger. So, final ROC sigma greater than minus 2. Because if sigma is greater than -2, automatically it is greater than -3. Simple. Okay. Okay. No, classes must be going on, Sudeep. Classes must be going on. Okay. And first of all, specify what your branch is, what subject you are talking about. Okay. Now, next part. Okay. E power minus 4t ut and e power minus 5t sin 5t ut. Okay. So, there will be a multiplication of sin 5t. Right. Okay. E power minus 5t sin 5t ut. अब देखो, let's deal with this. Let's come to the B part. So देखो, e power minus 4t ut. This is simple. For e power minus 4t ut, Laplace transform is 1 upon s plus 4. ROC, sigma greater than -4. Okay. Now the next is e power minus 5t into sin 5t into ut. Okay. Damned sinusoid. Okay. For e power minus 80 sin omega t ut, what it should be? It is given by omega, that is 5, divided by s plus 5. Okay. S plus e power minus 80 ka hai. S plus 5 whole square plus 5 square. What about the ROC? Now you can directly try to calculate the pole. Have a look into this. Okay. Okay. So now what about the pole here? The pole of this one, okay, s plus 5 whole square will be minus of 5 square. So if I take the under root, s plus 5 is under root 5 square will be 5 and under root of minus is plus minus j. So plus minus j5. So what is the pole? Minus 5 plus minus j5. Shifting the 5 on the right side. It is minus 5 plus minus j5. Okay. Right. See, Sudeep, I don't know what I'll just inform this to the course team. I don't know, the class will be there. Okay, maybe for some reason today it was not there. Maybe some issue sometimes happens with the faculty, but it will be there for you. Don't worry. It's not something that you should be really worried, and it's not the correct platform you're telling, because I don't belong to either computer science or to the course, but definitely I'll forward your words. To the course team. Okay, but you can drop a mail rather than putting it here. Okay, minus 5 plus minus j5. That should be the value of s. Okay, that should be the value of s. That is the pole. Now, signal is right-sided ut. So, ROC will be also right-sided. Whenever a signal is right-sided, ROC is right-sided. Okay, now what is the real part of the pole? Sigma is real part. Now, we can only compare with the real part. So, real part of the pole is minus 5. So, sigma greater than minus 5 will be written. Okay, so now when you add these two, okay. When you add these two, what is the final Laplace transform? As I told you, these are the two parts of the question given. When two signals are added, Laplace transform will also be added. Okay, Laplace transform will also be added. So you have 1 upon s plus 4. Okay, next will be plus 5 upon s plus 5 whole square plus 25. ठीक है. अच्छा, इसको भी simplify करेंगे. अगर s plus 5 whole square plus 25, तो s square plus 2ab will become 10s. Okay, plus 5 square 25 plus 25 50 हो जाएगा. ठीक है. And what is the combined ROC? Now you have two ROC, sigma greater than -4, sigma greater than -5. You have to take the intersection of them. So sigma greater than the greatest number. Okay, out of -4 and -5, the bigger number is -4. So ROC will be sigma greater than -4. Now you can add and simplify the expression. That you can do. Okay, right. How to deal with that? That I have completely given to you. Okay. So this is complete. Now let's go to the next part, that is the C. That is here, C. E power 2t u minus t, e power 3t u minus t. Okay, both are left-sided. Okay, both are left-sided. So let's deal with that. E power 2t u minus t, e power 3t u minus t. Just a second. Both are left-sided. So left-sided formula -1 upon s plus a. Okay, -1 upon s plus a. So Laplace transform for this one will be okay, -1 upon s minus 2 e power plus 2t. So a is like -2. So -1 upon s minus 2. For the next one, -1 upon s minus 3. But their individual ROC, left-sided sigma hai, so sigma less than 2. What is the pole? 2. But signal left-sided, so ROC also less than left-sided, sigma less than 2. Okay, for this ROC, sigma less than 3. And again, two signals are added, so you have to take the intersection. So what is my answer finally? Okay, ek to inko add kar denge, so minus will remain as it is. S plus S will be 2s. Okay, then here -3 and -2, -5 divided by s square. -2 -3 -5s, -2 into -3 plus 6. Okay, what is the final ROC, dear? What is the final ROC? Sigma should be less than 2, sigma should be less than 3. So sigma is less than 2 number, so it should be less than the lesser number to satisfy both. So sigma less than 2. Because it is guaranteed, if sigma less than 2, so automatically it is less than 3. Na? It is understood. Okay, so that is the common ROC here. Intersection is what you have to take. Intersection is what you have to take. Okay, going to the next question. Okay, t e power minus 2 mod t. So e power minus a mod t, you remember, t times property once again. So it's a property based question. Okay, going to the D. Okay, t e power minus 2 mod t. So what is the Laplace transform for e power minus 2 mod t? Okay, like e power minus a mod t, I will do minus 2s. Okay, minus 2a, sorry, minus 2a, a ka value 2 hai, divided by s square minus a square. That is the formula we also revised. Okay, so it is actually minus 4 upon s square minus 4. And the ROC is lying between minus a to a. A ka value 2 hai yahan pe. Right, so minus 2 less than sigma less than 2. ROC will be a strip. Minus 2 less than sigma less than 2. But now I want for t e power minus 2 mod t. What is the property we will use? Here, the Laplace transform for t xt is actually given by minus d by ds of xs. S differentiation property will come. S differentiation property. So its Laplace transform will be negative of d by ds of the above Laplace transform obtained. Right. So minus of minus plus 4 and 1 upon x differentiation. Minus aa jayega wapas 1 upon x differentiation minus 1 by x square. Okay, but by chain rule, when you differentiate the denominator again, it will be 2s. Okay, so your answer is actually minus 8s. Right, minus 8s upon s square minus 4 whole square. Minus 8s upon s square minus 4 whole square. That's what the answer is. Now, what about the ROC? Will the ROC change? Look into this. S square minus 4 whole square. What about the poles? Poles will still be, okay, when you solve this, s square minus 4 equal to 0, s equal to plus minus 2. Okay, and signal is two-sided because of e power minus a mod t. Okay, pole is between minus 2 and plus 2. Pole is minus 2 se plus. There are two poles, minus 2 plus 2, and signal is two-sided. So ROC should be between two poles, strip. So that means there is no change in the ROC. It will be like this only. Minus 2 less than sigma less than 2. Any doubts, keep asking me. Minus 2 less than sigma less than the 2. Okay, now this was the D part done. Let's come back here. Okay, to the question. Okay, now we have the E part. Mod t e power minus 2 mod t. Mod t e power minus 2 mod t. दोनों तरफ mod है. It's not only like previous one was t e power minus 2 mod t. Mod t e power minus 2 mod t. So how to deal with this? How to deal with this? Okay, so E part. What is the E part? The signal that is given to you is mod t e raised to the power minus 2 mod t. Okay, now we know that whenever t greater than 0, mod t is equal to t. Mod t will be t. Okay, whenever t is greater than equal to 0. But if t is negative, so what do you define mod t? Mod t is minus t in that case. Mod t is minus t. So ye ho gaya minus t. Okay, then if this is also minus t, this will become e power 2t. So ultimately, what is the signal? Signal you can write t e power minus 2t. T e power minus 2t. For t greater than 0, you can multiply ut. Na? Anyways, for t greater than 0, ut will be 1, otherwise 0. Okay, plus, what is the next part? Minus t e power 2t multiplied by u of minus t, because this is the part for negative value of time. For negative value of time, u minus t can be considered because u minus t will be defined for negative values of time. It will be 1, otherwise 0. Okay, so that's the standard practice. Now, whenever you want any signal for t greater than 0, you want multiplied by ut. Whenever you want for t less than 0, you multiplied by u minus t. So this is what is the xt. Okay, now dear, we already know, dhyan dena. Okay, we already know what is the Laplace transform for t power minus 2t ut. Okay, t power minus 80 ut 1 upon s plus a whole square. मैंने revise कराया 1 upon s plus a, that is 1 upon s plus 2 whole square with the ROC sigma greater than minus 2. Minus 2 is the pole and signal right sided to ROC right sided. Simple logic. Okay. Now, next property that you will use here is what is the Laplace transform for x minus t? Laplace transform for x minus t is given by x minus s. Okay, so that thing has to be used here because look into the second part. Second part and first part are related. Everywhere t replaced by minus t. T replaced by minus t, तो e power 2t हो गया. T replaced by minus t. So for minus t, e power plus 2t, u of minus t, Laplace transform will become x of minus s. That means in the s I will replace minus s. So 1 upon minus s plus 2 ka whole square. And what about this ROC? What about the ROC for the next signal? Now look into the pole. Minus s plus 2 equal to 0. So pole is still s equal to 2. Pole is at 2. But signal u minus t is left sided. Dekho, pole is at 2. But signal is left sided. So ROC should also be left of 2. Sigma less than 2. Sigma less than 2. Now what should be the answer? ROC sigma greater than minus 2 and sigma less than 2. दोनों को satisfy करना पड़ेगा ना? You have to satisfy both. Right? My signal is, let me write down the signal once again. T e power minus 2t ut. Right? Plus next part was minus t e power plus 2t u of minus t. Right? So what is my Laplace transform? My Laplace transform will be first wale ka tha. What is the first answer? 1 upon s plus 2 square. 1 upon s plus 2 square. Next is 1 upon minus s plus 2 whole square. Okay, and with the ROC minus 2 less than sigma less than 2. Because one of the ROC says sigma greater than minus 2, another one says sigma less than 2. You have to take the intersection, means sigma is greater than minus 2 but less than 2. Between minus 2 se 2. Okay. Now please add and write down the expression. That all you can do. Okay, just add and write down the expression. In dono ko add karna. I hope you can deal with that. Let me go to the next part. So what is the next part coming up? इसके बाद कुछ प्रॉपर्टी बेस्ड क्वेश्चन आएंगे. सो व्हाट इज द नेक्स्ट? mod t e पावर 2t u minus t. ओके, नेक्स्ट आया मेरे पास mod t e पावर प्लस 2t u minus t. ठीक है, mod t e पावर प्लस 2t u minus t. ठीक है, mod t e पावर 2t u minus t. f पार्ट पे चलते हैं. ओके ओके, f पार्ट mod t e पावर प्लस 2t बट विथ u minus t. अच्छा, u minus t का मतलब ही है u minus t means u minus t will exist for negative values of time, and if the time is negative, mod t will be taken as actually minus t. So minus t e power 2t u minus t. Okay, you can take its answer from the previous part. I've already told you the answer from the previous part. Okay, what was the answer from the previous part? 1 upon minus s plus 2 whole square. Exactly यही तो solve किया. Exactly यही तो solve किया था. 1 upon minus s plus 2 whole square. ROC also I explained sigma less than 2. ROC also explained sigma less than 2 because of left-sided signal. That's it. Done. Just like the previous part. So this part was already discussed. It is a sub part, you can see. Okay. Now after f, what is the next part you have? Right. What is the next part you have? ये हो गया f. Okay, I and j, some of the parts I have taken. Delta t plus ut and next is delta 3t plus u 3t. Both are related. So let's solve with delta t plus ut. Delta t plus ut. Okay. Okay. So I part, simple hai. I part, what is the xt given? This one is simple actually. Delta t plus ut. Okay, so what is its Laplace transform? Its Laplace transform, delta t Laplace transform 1, ut Laplace transform 1 by s. So if you simplify, you get s plus 1, correct hai na? S plus 1 divided by s. Acha, what about ROC? What about the ROC? This does not have any pole. ROC entire s plane. Okay, 1 upon s. Laplace transform of ut, the ROC sigma greater than 0 because pole is 0 na? because pole is 0 and signal is ut, right-sided. So ROC also right-sided, sigma greater than 0. So overall also ROC is sigma greater than 0. Okay, sigma greater than 0. Acha. Okay. Now next part was delta 3t plus u3t. Okay, let's say this signal is yt. Isko main rename karta hu. And if you compare to the previous, only thing is t is replaced by 3t in both the signals. That means if you compare to the previous signal, it is known as x3t. Okay, x3t. Okay. No, not only exception, sigma greater than 0 because of the right-sided nature. Bhanu. Okay, 0 will be excluded, but towards the right of 0 actually you have to go. Left mein nahi ja sakte. Okay, this is x3t. Now, what is the scaling property of Laplace transform? Hey, what is the scaling property of Laplace transform? Okay, x of at Laplace transform. X of at Laplace transform is 1 upon mod a x of s by a. 1 upon mod a x of s by a. So 1 upon 3 x of s by 3. That is 1 upon 3 x of s by 3. So replace s by s plus s by 3. So s by 3 plus 1 upon s by 3 multiplying throughout by 3. You will get s plus 3. Denominator by s and this is 3. So divided by 3s. Answer will be s plus 3 upon 3s. That's the answer. Achha, at the same time, what will be the ROC? Again, just look into the pole. Na? See, with any Laplace transform property, you should not remember ROC results. You should only remember the ROC logic always in Laplace transform. Okay, pole is at 0. Pole is at 0, na? 3s, pole is at 0. Signal to right-sided, hai, na, sir? U3t is coming up. U plus t anytime it is right-sided. So ROC, okay, first of all, write down the pole 0. Greater than or less than? Greater than, because signal right-sided, so ROC also right-sided. Done. So ROC remains to be same. Answer is s plus 3 upon 3s for the Laplace transform. Okay. Let us go to the next question, dear. So what is the next question? Now this is just based on ROC. There will be several questions. There can be several questions from Laplace transform only that is discussed on the ROC. Okay. So consider the LTI system for which the system function HS has the pole 0 pattern shown in this figure. Okay, there is a pole 0 pattern shown in this figure. Okay, indicate all possible ROCs. सबसे पहले क्या बोला है? Indicate all possible ROCs that can be associated with this pole 0 pattern. For each ROC, specify whether the associated system is stable and or causal. चलो वो भी बता देंगे. Okay, indicate all possible ROCs. Okay, so you know what are the three cases of ROC? ROC can be right-sided or left-sided or between two poles, a strip between two poles. Or the last case is ROC is entire S-plane, but that is only possible when you don't have any poles. Here you have poles, na? So first case, one by one. I've just taken this diagram here. Case number 1. And the ROC, let's take to be right-sided. Let's take to be right-sided. Okay, right-sided. And right-sided is lying to the right of the rightmost pole. Sigma greater than 1. Sigma greater than 1. Right-sided ROC will always lie to the right of the rightmost pole. Let me sketch that ROC here. Okay. Sigma greater than 1. Acha. Now, because the ROC is right-sided, you have to also indicate in each part whether the system is causal and or stable. So, because of right-sided ROC, system is causal. Okay, but what is the condition for stability? A system is stable if the ROC includes the j omega axis, if the ROC includes the imaginary axis. So, is the imaginary axis included? No, dear, it is not included. So, it is unstable. You have to just make the remarks. So, these are pure conceptual questions on to which gate questions are also dependent. So, please be attentive here. Okay, next part. Achha, next type of ROC. Let me take the next. Now, one is right-sided. Ab next le lete hain left-sided. Okay, second case. Let me now define for you a left-sided ROC. Left-sided ROC will always lie to the left of the leftmost pole. Will always lie to the left of the leftmost pole. So this is the leftmost pole, -2. And ROC will be towards the left of this. ROC will be towards the left of this. That is sigma is less than -2. Is this system causal? No, it is not. Right-sided ROC system is not causal. Actually, the ROC is strictly opposite to causal. So we call this as anti-causal. Okay, whenever ROC is strictly left-sided, we also call the system as anti-causal. Does it include the imaginary axis? No. So it is unstable. So it is unstable. Done. Okay, so this is the second case. Okay, now right-sided ROC done, left-sided ROC done. What is the next possible ROC? Between two poles, a finite strip. Okay, but between two poles also, okay, see, it can be between -2 and -1, number one case. It can also be between -1 to +1. There can be another case. So there will be two cases of finite strip. Can it be between -2 से +1 directly? Between these two poles? No. You cannot take between -2 से +1 because in between a pole will come and ROC cannot include pole. ROC cannot include poles. That is the first ethics about ROC you should always remember. ठीक है, तो इसलिए चलते हैं next part की तरफ. Okay, let's go to the next part. The third one, okay, strip ROC. Finite strip ROC और इसके भी दो केस होंगे. Okay, the finite strip ROC also there will be two cases. Okay, so number 3 and यहाँ पे number 3 अलग से लिख लेते हैं. Finite strip ROC that is between -2 से -1. -2 less than sigma less than -1. Okay, ROC is as shown here. -2 से -1 के बीच में. This is a valid ROC because it is between two poles and it does not contain any pole in between. This one is okay. ठीक है. Clearly ROC is not right-sided. It is causal, not causal. Is it left-sided? तो anti-causal भी नहीं है. It is randomly a finite strip. So we simply call it as non-causal. Does it include the j omega axis? Not at all. So it is unstable. It is unstable. Okay. But for the finite strip ROC also, there will be one more case here. There will be one more case. So that is the number 4. That is the number 4. And that is, okay, between -1 to +1. That's also a valid ROC. Between the -1 to the +1. That will also be a valid ROC. That will also be a valid ROC. So next, once again, finite strip ROC. Once again, finite strip ROC. Case number 4. -1 less than sigma less than 1. Okay. ROC is not right-sided. Okay. So causal to nahi hai. If it is strictly left-sided, we call anti-causal, but it is neither right nor left. It is simply non-causal. But this time it includes the j omega axis. Okay, so that is why it's stable. Okay, it includes the j omega axis. Right. It is stable because it includes the j omega axis. Okay. So it is stable also. So for each of the ROC, you also had to comment on stability, causality. Okay, such concepts and such questions very important for competitive exam. Very important for the competitive exam, right? Okay. Chalo, next. Okay, so before we go to the next, guys, an update for you that yes, the next MMC will be now live from 11th of November. Yes, the All India Open Mock Test, okay, on the BYJU'S exam prep app are available for you, and these are all India open mocks. Open mocks means it is free. Every student can appear in it. Initially, some of the tests are subject test, and then in December, full length test will also start. The tests are as per gate pattern, 65 questions, 100 marks for 180 minutes. And also, guys, if you perform in these tests, if your name comes up in the result, like the next MMC starts from 11 to 17, and for EC, it is actually for all branches, but let me tell the syllabus for EC. Okay, for next test that is starting, it is EDC and unlock circuits. Result will be on 18th November. And if you perform and if you get your name in top in the results list, you also get huge discounts on the BYJU'S test series. Okay, so you get more and more tests in the BYJU'S test series, more full-length tests, more subject tests, topic tests, etc. Okay, now we have the next question. We are given the following 5 facts about the real signal xt with the Laplace transform. Again, okay, very, very relevant to the gate exam type questions. Some facts about a signal given, we need to determine what the signal could be. Okay, XS, it's about the real signal xt. Okay, the signal is real. Okay, and the Laplace transform is xt. XS, Laplace transform is XS. It has exactly 2 poles. XS has no zeros in the finite S plane. XS has a pole at -1 plus j. Acha. Whenever there is a real signal, poles and zeros will always appear in the complex conjugate form. If it is complex, it will be conjugate pair. Right. So if there is a pole at -1 plus j, there will be a pole at -1 minus j also. Conjugate pair hoga. Okay, because of real signal, you will have conjugate poles or zeros. Right, so both the poles are known to us. It has 2 poles and both the poles are known to us. Okay, e power 2t xt is not absolutely integrable, इसकी बात करेंगे. If it is not absolutely integrable, Fourier transform does not exist. ठीक है. अच्छा, so देखो, what we know is fourth point को यही लिखते हैं. If xt is having the Laplace transform xs, okay, whose ROC is suppose r, okay, then for e power 2t ut, exponential term in the time domain corresponds to s shifting. So for e power 2t xt, actually the Laplace transform is given by x of s minus 2. The Laplace transform is actually given by x of s minus 2, right? S shifting property, frequency shifting property. Okay, and because of x of s minus 2, pole is shifted and ROC is also shifted. Okay, ROC is also shifted. Okay, the ROC also can be written as r minus 2. Okay, ROC is actually right shifted by 2 units, you can feel, because the pole are shifted. ROC is totally dependent on pole, na? Pole right की तरफ जाएंगे तो ROC भी right की तरफ shift हो जाएगा. But this e power 2t xt is not absolutely integrable. Okay, that means its Fourier transform does not exist. That means this ROC, r minus 2, after shifting the poles, okay, will not include the j omega axis. Not absolutely integrable means ROC not includes the j omega axis. Okay, and x of 0 is equal to 8. Now first of all, there are two poles and there are no zeros in the finite s plane. Okay, so only there are two poles. So what is the excess? What is the nature of the excess from these three parts? Okay, from these three parts, what is the nature of the excess, dear? You can try to write down excess as there are no zeros, so numerator can be only taken as some constant k divided by the poles are plus minus 1 plus minus j. देखो, s minus 1 plus j. What should be there in the denominator? S minus 1 minus j. Right? Okay, so it is like s plus 1 minus j, s plus 1 plus j. A plus b, a minus b. When you simplify and you open it, you are going to get s square plus 2s plus 2. Multiply and get, you will get s square plus 2s plus 2. So because poles are known to me, I can write down the denominator expression s square plus 2s plus 2. Numerator only k because there are no finite zeros. There are no finite zeros. Done it? Okay, that is what is excess. That is what is the idea that I can apply to the excess. Okay, that is the idea that I can apply to the excess. K upon s square plus 2s plus 2. अच्छा, x0 is equal to 8. यहां से भी आइडिया आ जाएगा अबाउट द के, राइट? x0 is equal to 8. अच्छा, x0 will be k upon 2. ये देखोगे ना यहाँ पे. Okay, k upon 2 if you put s equal to 0. So k upon 2 equal to 8, meaning that k is equal to 16. So what is the excess? What is the excess? Okay, k का वैल्यू आ गया तो 16 upon s square plus 2s plus 2. तो excess तो आ गया. One part is done. Okay, using some points. Okay, and specify the ROC. Now there are two poles at minus 1 plus minus j. Now understand the next important part. Okay, minus 1 plus minus j. Right. You have minus 1 plus j, minus 1 minus j. Right. But you are also given an additional information. That, what is the additional information? That if the ROC was shifted, ROC for e power 2t xt should not include the j omega axis. What is the ROC for e power 2t xt? Okay, it will be right shifted by 2 units because Laplace transform is x of s minus 2. So if you right shift the poles, okay, by 2 units, यहाँ पे आ जाएंगे poles. Poles will come at 1 plus minus j. Okay, this is 1 plus j, this is 1 minus j, right? And for these particular set of poles, ROC should not include the j omega axis. So where should be ROC? Okay, either right or left. It should be actually right. It should be actually right. Because if you take the ROC left, j omega axis will come. Okay, so original ROC should also be right. Only ROC is shifted, na? So what is the idea about ROC? What is the idea about the ROC? What is the idea about ROC? Okay, ROC should be sigma greater than, right ki taraf. What? Greater than minus 1. This point is minus 1 actually. We have to compare only with respect to real part. Sigma greater than minus 1. Done? Any doubt, please keep asking me. Okay, sigma greater than minus 1. Done. Right. So determine x's and specify the ROC. Both parts are there. A beautiful conceptual question. यही conceptual level आपको develop करना है. It's really a conceptual level question. Okay. It's really a conceptual level question. Next question. Determine which, if any, of the following pole zero plots in figure given could correspond to even function of time. What? Could correspond to even function of time. Okay, for those that could indicate the required ROC. अब देखो, even function of time. Okay, first of all, xt is even. Okay. Acha, for a signal to be even means what? Left and right are identical. Okay, a signal and its mirror image are identical. So a signal can only be even if the right side portion is identical to the left side. Okay, right side identical to the left side. So that means signal should have both the parts right and left. Maybe till infinity or not, but it should have both the parts right and left. So if a signal is even, one thing we can conclude here, if a signal is even, one thing we can conclude that xt should be either two-sided.
I didn't get that.
Okay, something like this. Something like this, two-sided till infinity, or it could be finite duration.
Sorry, I'm still not sure about that.
Or it should be finite duration. Right, something like this, like a triangular pulse. Okay, signal on the right and left identical. Okay, but it cannot be. One thing is sure, it cannot be a right-sided or left-sided signal. It cannot be purely a right-sided because it cannot only go towards right. If it is going to right infinity, it should go to left minus infinity. Then only symmetry will come. Na? So that is why if it is going to infinity, it will be two-sided, both-sided, or it will be finite duration, something like this triangle. Okay, signal on the left and right identical. कुछ ऐसा होना चाहिए. ठीक है. Now, this is one case. Now, next what we know dear is, they are telling x minus t is equal to xt. That is what even symmetry means. What is the Laplace transform? If two signals are equal, Laplace transform will be equal. So xt Laplace is xs, but what is the Laplace of x minus t? We used in the previous questions, x minus s. Okay, folding property. So x minus s should also be equal to xs. ठीक है. अब आते हैं one by one. Okay, option number A. Dear, option number A. There is a pole. Okay, option number A, there is a pole at origin. So I will write down s in the numerator. Sorry, there is a 0 at origin. So write s in the numerator. There are poles at plus minus 1. There are poles at plus minus 1. Okay. So s square minus 1. If you want poles at plus minus 1, so plus minus 1 are the roots of s square minus 1. S square equal to plus 1. Okay. Na. Vanu. Previous question is telling the ROC for e power 2t ut should not include the j omega axis. It was for e power 2t xt, not for xt. Okay, I explained with respect to that. Okay, if I go back to the previous question, yeah, let me complete this once. Okay, isko beech mein break nahi karte. What can be the transfer function corresponding to the next? Okay, k, some constant k. Now there are zeros at plus minus 1. Okay, plus minus 1 are the roots of s square minus 1. So that should be the numerator because they are the zeros. There is a pole at origin, so divided by s. Okay, divided by s. Okay, third part pe aate hain. Okay, the transfer function possible here is, okay, there are the zeros at plus minus j. Okay, plus minus j, matlab s square plus 1. Plus minus j under root of minus 1 hota hai. Okay, there are poles at plus minus 1, so s square minus 1. Okay, now have a look into this. Have a look into this. Next one. Okay, there is a 0 at plus 1. So s minus 1 is the factor. There is a pole at s equal to minus 1. So denominator mein s plus 1. So that the pole becomes minus 1. Okay. Now, if you check actually, the first A option, and if you try to put x minus s, okay, minus s ka square will be unchanged, but there is a minus s clear term here. X minus s will be negative of xs. One minus will be left out. When you replace s by minus s, there will be one minus remaining outside. Okay, so if you go for option B, okay, there also same story. Minus s square will be s, but there is a minus in the denominator that you can take outside. So when you take x of minus s, one minus is still left. So that is minus of xs. Okay, option number C. If you replace s by minus s, in the option number C, if you replace s by minus s, so x of minus s will be xs because both the places minus s ka square will become s square. There is no effect in the function. So option number C is going to satisfy. और D में तो कुछ satisfy नहीं होगा. If you replace s by minus s, if you are going to replace s by minus s, it's going to be some random function. Okay, but neither even nor odd. So the property that I told you in the next slide, x minus s is equal to xs. Okay, that is only satisfied by the figure C. Okay, okay. So that could correspond to even function of time. Okay. And for those that could indicate the ROC, the only C can specify an even function. And if it is an even function, please specify the ROC. So there are two poles. And I told you, signal can either be finite duration. But if a signal is finite duration, ROC is the entire S-plane, cannot contain any pole. So finite duration nahi ho sakta. Okay. But signal can be two-sided. And for two-sided, what is the ROC? Strip between two poles. Okay, so what are the two poles? -1 and +1. Okay, so for corresponding to C, ROC will be -1 less than sigma less than 1. Strip between the two poles -1 and 1. It is going to be the strip between the two poles -1 and 1. Clear? So done. Only option number C, only figure number C could specify even function of time. Now in case they can put it as a MCQ or even MSQ question. Okay, they can give you 4 options. Okay, forget the ROC. They can ask which of the pole zero plots correspond to even function of time. It becomes a beautiful conceptual question. Which of the following pole zero plots correspond to even function of time? And what I need to check is x of minus s is equal to x of s. From the pole zero knowledge, I can get out the transfer function. Okay. Yeah, Bhanu, going to your doubt of the last question, may look into this. E power 2t xt is not integrable. That means when you take its Laplace transform, it is x of s minus 2 by a shifting property. Okay, pole is shifted by 2. So ROC also shifted by 2. That shifted ROC should not include the j omega axis. Dhyan dena. So please, okay, these are the two poles. Shift the poles right. Poles yahan pe aa jayenge. Now think. Okay, this is the line from which ROC can start. ROC can be left or can be right. Okay, but for the shifted ROC, j omega axis should not come. So where should be ROC going? Towards right. So that means original ROC should also be towards right. That is the idea we wanted to get. Okay, because let me erase it now. What you are able to sense is that ROC is just shifted. But if the original ROC is right, shifted ROC will also be right, na? तो मैंने आपको ये प्रूव किया, shifted ROC is right, so original ROC will also be right. Means, okay, this is the line. Okay, either ROC could be less than -1 or greater than -1. I want greater than -1 because it should be right-sided. Hope it is clear to you. Hope it is now clear to you. And this was also a good question. MSQ भी बन सकता है यहाँ से. From here, we can define a MSQ type of question also. Okay, we can define a MSQ type of question as well. Right. Next question. Right. What is that you're looking for, Shreyansh? Hanji. E power 2t xt being unstable. Redox, okay? E power 2t xt. So actually from e power 2t xt, we wanted to come to the analysis of xt. Consider a continuous time LTI system for which the input xt and output yt are related by the differential equation. Let xs, ys be the Laplace transform of xt and yt. Okay, and let hs denotes the Laplace transform of ht, that is the system impulse response. Okay, determine hs. Hs means transfer function. Transfer function can only be defined for zero initial condition. Okay, can only be defined for zero initial condition. So for zero initial condition, let me solve it here only. Okay, converting to the Laplace transform, s square ys. Okay, minus sys dy dt s, second derivative s square minus 2ys is equal to xt, and xt Laplace transform is xs. Okay, so from here, okay, we want to get the ratio of output to the input Laplace transform, and that is what is known as the transfer function hs. The ratio of ys upon xs will actually become 1 divided by s square. Okay, minus s minus 2. 1 upon s square minus s minus 2. Okay, determine hs as a ratio of two polynomials. Here we have got. Okay, pole zeros can also be obtained, and determine ht for each of the following cases. This is a regular question. ये ज़्यादा difficult नहीं है. So I have got my transfer function as 1 upon s square minus s minus 2, which I can easily factorize as, okay, 1 upon s minus 2, then s plus 1. Minus 2 plus 1 will give you minus 1. Minus 2 into plus 1 will be the minus 2. So 1 upon s minus 2, s plus 1. One upon s minus 2 into the s plus 1. ठीक है, that is what it is. अच्छा जी. So here poles also are obtained. But now next step is, because you want to get ht also, better split into partial fraction right now only. So let me try the partial fraction. 1 upon s minus 2 minus 1 upon s plus 1. So s plus 1 minus s minus 2. S and s cancelled. 1 plus 2, 3 आ जाएगा. But I don't want 3. So I will multiply by 1 by 3. So that after subtracting जो 3 आएगा, that is cancelled with the 3. This is what is the hs. Okay, but without ROC, I cannot say what is the ht, because 1 upon s plus 1, this comes in e power minus tut also, e power minus tu minus t also, depending on ROC. So there are 3 cases of ROC given. So first of all, what are the poles? What are the poles? Poles is s is equal to minus 1 and plus 2. These are the 2 poles, and hence 3 types of ROCs. ठीक है, अब क्या बोला है? The system should be stable. Determine ht if the system is stable. Okay, if the system is stable. Okay, first part, you want stable system. You want stable system. For a system to be stable, ROC should include what? For a stable system, ROC should include what? तीनों केस एक साथ कर डालते हैं बोले तो. First, stable. Okay. What is the second they have told? Okay, causal. Third, neither stable nor causal. Second, causal. Third, okay, none. That is neither stable, ना stable होना चाहिए, ना causal होना चाहिए. अच्छा, what is the ROC correspondingly? Okay. What is the ROC correspondingly? We have the 2 poles, everybody. We have the 2 poles, minus 1 and plus 2. Minus 1 and plus 2. ठीक है, नेक्स्ट केस पे भी ROC बना देते हैं. ओके, वी हैव द 2 पोल्स minus 1 and plus 2. नेक्स्ट केस we have again the 2 poles minus 1 and plus 2. ठीक है, now system is stable, तो ROC should include the j omega axis. So what is my ROC? What is my ROC? To include the j omega axis, I should take the ROC between minus 1 and plus 2. Minus 1 less than sigma less than the 2. So dear, what is the hs that we obtained? Hs was 1 upon s minus 2 minus 1 upon s plus 1. Okay, take its inverse Laplace transform ht. So it is going to be, pay attention, okay, with respect to the pole 2, you have to see with respect to individual pole. So with respect to the pole 2, ROC is towards left. Okay, ROC towards left mean u minus t formula. 1 upon s minus 2. So minus e power 2t u minus t. U minus t. Minus. Now next pole will be minus 1. And with respect to minus 1, ROC is towards right. Right means ut formula. Okay, so next part will have the ut formula. So that is e power minus t ut. E power minus t ut. That is the answer. Okay, impulse response for the first question. ठीक है, next पे आ जाते हैं. So next, I want the system to be causal, and a system is causal if the ROC is right-sided. So what is the possible ROC here? Right-sided always will lie to the right of the rightmost pole. Will always lie to the right of rightmost pole. Okay, so what is the possibility for ROC here? ROC sigma greater than 2. That is the only possible ROC. So let me again write down the HS first of all. What is the HS? 1 by 3. Transfer function the same hai. 3 different cases of ROC based on the nature of the system. Okay, but if the sigma is greater than 2, sigma is also greater than minus 1. So with respect to both the poles, sigma is greater. With respect to both the poles, sigma is greater. So both the places you will have the ut formula. Okay, both the places you will have the ut formula. So 1/3 1 upon s minus 2 तो e power 2t ut दोनों में ut आएगा 1 upon s plus 1 तो e power minus t ut. ठीक है, done. Both contain ut. Then only causality will come. No? Causal means ht should be containing ut part only. Neither stable nor causal. Right. So there are three possible ROCs with two poles. Okay. Right-sided. Okay. If you take right-sided, it is causal. I don't want causal. Either finite strip between two poles. If you take finite strip between two poles, so j omega is coming in between, stable. So only possibility now left is to take the third ROC case, that is to the left of -1. That is to the left of the -1. So what is the next possible ROC? Sigma less than -1. Okay, now let me again write down the HS. 1/3 1 upon s minus 2 minus 1 upon s plus 1. Okay, if sigma is less than -1, automatically it is less than 2 also. So for with respect to both the poles, it is less. Less matlab u minus t formula. U minus t formula. 1 upon s plus a. So minus e power 2t u minus t. 1 upon s plus 1. So minus actually plus e power minus t u of minus t. Both will contain u of minus t, and this actually becomes the case of anti-causal. Okay. Non-causal to hai, but specifically we can call it as the anti-causal. ठीक है. Okay. Next question. Okay. Chalo, a good question. A causal LTI system with the impulse response ht has the following properties. When the input to the system is e power 2t for all t, the output is 1/6 e power 2t for all t. ठीक है. Impulse response ht satisfies the differential equation. Okay. So impulse response satisfies some differential equation. So here, if you convert to the S domain, S into HS plus 2ht, so 2hs is equal to e power minus 4t ut, Laplace transform, Laplace domain में जा रहे हैं तो 1 upon s plus 4 plus b ut Laplace is 1/s, तो plus b upon s. ये लिख सकते हैं हम लोग. So from here I am able to get some idea about the hs. Okay. What is that hs? Yeah, s plus 2 common, divide on the right side. So 1 upon s plus 2. 1 upon s plus 4 plus b by s. 1 upon s plus 4 plus b by s. Okay, determine the system function hs consistent with the information. There should be no unknown constants in your answer. That is, the constant b should not appear. So right now hs contains b. How to get the value of b? Okay, now let us come to the first point. When the input is e power 2t for all t, input is of the form e power st. That is known as the input is of the form e power st, eigen input, eigen signal. The e power st, the complex exponential signal is actually known as the eigen signal to LTI systems, to continuous time LTI system. Okay, and what is the output for this eigen signal? Okay, it is the same e power st multiplied by hs. Then only we call it as eigen signal. The response is very similar to what is the input, only multiplied by some factor, that is hs. Okay, and that is what is given. Okay, actually for this yt, for this xt, yt is given as 1/6 e power 2t. यही given है ना? 1/6 e power 2t. Okay, now for e power 2t, actually the output should be like e power st into hs. So for e power 2t, it should be h2 into e power 2t. So इन दोनों को compare करके, you can say that the value of h2 is 1/6. The value of h2 is 1/6. And now what is the hs? Let's take up this form of hs once again. hs, as per the second part, hs was obtained as 1 upon s plus 2 into 1 upon s plus 4 plus b by s. We are going to use the point that h of 2 is 1/6. h of 2, so 2 plus 2, 4, 1/4. 2 plus 4, 6, 1/6 plus b by s. s की जगह 2 रखते जा रहे हैं. Okay, and this should be 1/6. So 1/6 plus b by 2. shift 4 on the right side, 4 by 6. Yeah, that can be, okay, this is 4 by 6. So what is b by 2? 4 minus 1, that is 3 by 6, or that is 1 by 2. 2 से 2 cancel, b is equal to 1. Okay. Now if b is equal to 1, then hs is nothing but 1 upon s plus 2. थोड़ा सा simplify करेंगे, 1 upon s plus 4 plus b. b is 1, तो plus 1 by s. Okay, so s plus 4, 2s plus 4. It actually becomes 2s plus 4 upon s plus 2 into s plus 4 into s. Okay, take the 2 common. If you take 2 common, s plus 2 will get cancelled. So you are only left with 2 by s plus 4. Right? That is your answer. What is the complete system transfer function? 2 by s plus 4. It is 2 by s plus 4. 2 by s plus 4. That's what it is. So guys, parallelly on the BYJU'S exam prep app also, you can enjoy several practice sessions. Okay, the practice sessions in the live form, or the practice quizzes also available. The timer based, you can appear on those quizzes at any time at your convenience. Right. You can get the BYJU'S exam prep app from the Google Play Store, or there is a link in this description of the same video. You can directly download the app using the link, but participate in several quizzes and compete with your fellow GATE aspirants. Okay, more and more quizzes you appear, more and more points you get, and then maybe sometimes you're at the top of the leaderboard. Okay, throughout your GATE preparation journey. So that can make your preparation journey interesting, and as well as you want as much practice as possible. So you can utilize our app for more and more practice. Okay. So also guys, if you want a quick revision course for GATE 2024, so crash course is live, quick revision, fast track revision theory, along with different all variety of questions relevant for GATE. And also guys, if you're looking for full-fledged preparation of GATE 2025 or 26, the vision courses, full-fledged courses available in both the languages, English as well as Hindi. You can choose any of your batch as per your requirement, and in all of these batches you get live classes. You have the option of recorded lectures also, study material, mock test, practice quizzes, everything to make you exam ready will be definitely provided. Okay, and the guidance will be under your best faculty team. You must have followed their classes and you must be knowing them from the YouTube. Okay, so that you can take a decision. Okay, so you'll get the today's PDF in my Telegram group. Okay, and the password for the today's PDF will be, okay, the password will be ROC, everything in small. Okay. And I don't know, after some days we have resumed the OpenHEM series. Okay, but suddenly today I felt that students have now lost interest. Okay, next session is on Wednesday, Z transform. If you're really interested, if you want me to go forward, let me take. Otherwise, there is no point if the students are not attentive and showing less response, because these sessions take effort. Choosing the correct set of questions, deciding which question can actually relate with the GATE and can come up with the GATE, discussing those questions. So if students are not interested, then why I should take the effort? So think about this, if you need the Z transform session or not. Okay, today's PDF you will get in the Telegram with the password protection ROC. Okay, with the password protection of ROC. Okay guys, so if you're interested, then we can plan the next session Wednesday. It will be alternate as we were continuing earlier. Same time, 9 p.m. Okay, bye-bye. Good night. Thank you. Stay safe and do take care of yourself.